first thing first, by starting with data analytics. In data analytics domain, we are providing some existing data sets of a company, business, movie, sports, etc. And when we get the data sets, sometimes the data set is in unordered format, or sometimes the data set is in ordered format. So if we get the data set in unordered format, then we have to perform some operations on that unordered data set, so that we can make the unordered data set in the format of ordered data set. After getting the ordered data set, we have to perform statistical analysis on that. To perform the statistical analysis on the ordered data set, we have to create dashboard and reports. Basically, dashboard and reports are contain some charts and graphs, line graphs, bar chart, pie chart, something like that. By clubbing the some charts and graph, we get our dashboard and reports. And when we are creating our dashboard and reports, we have to keep some things or points in our mind, that if a technical or non-technical or a businessman came and see our dashboard, then they can easily understand that, and can extract the insights from that dashboard or report easily. So basically, at last, I can say that in data analytics, we have to organize our data so that anyone can came and uncover the actionable insights from that data set. So we have to establish our data in the best way. Okay, and then we are going to move at different, like, next topic, or you can say our last topic of this session, which is levels of data analytics. There are 4 levels of data analytics, which is descriptive analytics, diagnostic analytics, predictive analysis, and prescriptive analysis. So in descriptive analysis, we this is the basic and the important step of the data analytics, where when we have to start with data analytics, we have to perform some, you can say, we have to take a path, where this is the first step, or you can say this is the first level of that path. And this is the basic, and it is the most important and vital step, because if we do something wrong in this step, then the whole procedure goes wrong and wrong, and at last we can't do the right step, and we can't take the right step or take the right decision for our company. So this is the basic, but also this is the most important and vital step for our data analytics. So in this, we have to make dashboard and reports, and choose the graphs, which graphs we have to use in this, which charts we have to use in this, make it more user friendly, make it more attractive, so can anyone can came and grab the insights from that dashboard and reports. And when we finish with this, our dashboard and reports, we complete our first level of data analytics and goes to the second level, which is diagnostic analytics. By when we make our dashboard and reports with the charts and graphs, then our next step is grab the insights from that dashboard and charts. And this grabbing of insight is known as diagnostic analysis, where we have to diagnose that dashboard and reports to get the insights, and choose those insights which were look good, not the unfamiliar insights which are have nothing relevant to our company. So by choosing those insights and grab this that insights, we have to mark those, that something in Excel, or you can say something where something in notepad or something like that, where we can use those insights in our next step. So when we get our insights in our diagnostic analysis level, we goes to our next level, or you can say next step, which is predictive analysis. In predictive analysis, we have to predict, is our company going in right path or a wrong path. Like, if our company in after 10 years, will it growing more revenue, will it getting more profit or not. And by just using some machine learning algorithms, using artificial intelligence, when we predict whether our company is going in right path or wrong path, we predict that. And after get the prediction, we club our prediction and insights and do our final step, which is prescriptive analysis, where we have to take the decisions for our company, that which steps should we take for our company, so that our company move in right path, where our company grow more and more revenue, where our company get more profit, and go ahead with the competitors company and move much forward from the right now position. So these all levels, or you can say these all steps, are come under the data analytics. These are the 4 steps, and I hope I managed to clear your all doubts and managed to transfer all the information of basics of data analytics. So I hope you all understand the basics of data analytics. So that's all for today's session. Thank you. Bye bye. Take care and keep learning. Hello, guys. How are you? In today's session, we are going to talk about data science, data mining, statistics, machine learning, supervised and non supervised techniques. So, these are the topics for our today's session. So, without wasting any time, let's get into this. So, in today's session, our first topic is data science. As you see by the left diagram, here you see some domains like data engineering, scientific method, math, statistics, advanced computing, visualization, hacker mindset, domain expertise. By combining all these fields and domains, we get our full package of data science. If a person or an employee get to know about all these domains, all these 8 domains, then we can say that that employee is perfect for doing the data science job. And thereby you can say that if you want to came in the field of data science, then you have to know about these domains. And for that, the first part which you have to do if you came in this data science domain, then there are 4 basic pillars for that data science, which is business domain, mathematics, computer science, and communication. These 4 pillars are essential for you if you are trying to become uh, a data scientist or trying to come in the data science domain. Then you have to essentially know about all these 4 pillars. And in data science job, your job is to, like, first, when you get your data, you have to convert your data in such a way that anyone can visualize that data and grab insight from that. Like, you have to make graphs and charts from the data you have got from your company, and after making graphs and chart, you have to grab some insights from that. And after grabbing insights, you have to take decision. And when you take decision, you apply the machine learning and deep learning models on that decision. Like, if I am taking this decision, then after n number of years, where is my company position? So by using these machine learning and deep learning models, you get to know that by applying this decision on my company, where what is the position of my company in near future. So by using that, if the decision is good for your company, then you take that decision, and if the decision is not good for your company, then you bypass that decision. And after this, we came to our next topic, which is data mining. Data mining is a process used by a company to turn raw data into useful information. Like, when you came into a company and you have to do a job of data mining, then you have to grab the data. Then you have to grab the useful information, useful data from the data warehouse of the company, company store all of where company stores all of its data. And from that data you have to grab only those data which is useful for your company. So for grabbing the data, you have 5 steps which is involved in data mining. First step is identify the data. You have to identify what kind of data you want from the your company's data warehouse, your raw data, what kind of data you want from that. And after identifying the kind of data you want, then you prepare that data by getting that data from the raw data. You prepare your data and evaluate your data, like, is your data is correct or not, the data you get from the raw data is in correct order or not. Like, like, if you grab your data in CSV format and you have some columns and rows in that, so you see that there is a column which is name, and in the name column, the fields having the fields having the values in the number format. Like, in name column, first row has 1 2 3 4. In name column, second row has 2 3 4. So data is in not a correct format, because 1234 isn't a name of any person. So you have to evaluate your data, that that data is correct or not, and after evaluating that you have to present your data in a correct format so that anyone can use your data in further processes. And after presenting that data, then you use that data for business goals, and that all the 5 steps which comes under the data mining process. And after this topic we are going to next our topic, which is statistics. Statistics is a discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. As you can see on left image, if you want to make graphs, charts, then you use statistics for making that line, graphs, bar chart, and pie chart, because statistics is a basic block and everywhere. Like if you want to came in any field, and I want to say that fields like data analytics, data science, business analyst, in if you want to came in this field, then statistics is the basic block. For that you have to know about these statistics because it is an essential domain for that. And on the right side image you all can see that statistics are used in various fields, like in our day-to-day life, like predictions, testing, forecasts, preparations, predicting political, insurance, consumer, finance, sports, in all these domains. And there are more domains where statistics is used, and essential and basic block for that. Then comes our machine learning part. In machine learning part, you have to make the models for your data, where you get the you get some rules from the input and output data set. Like if you get some input data set and also get the output for that input data set, by using the machine learning models you get to know about the rules from that. Like first, like when you like see the left block diagram, when you get the input data, then you have to train the models. For train the models, see the right chart. You have to first problem the you have to first make the problem formulation, then you have to do feature extraction, then you have to do model selection, like what kind of model, what kind of algorithm you want to use in your machine learning. Then you have to do model implementation, you have to implement that model, then you have to evaluate that model. And after that, come on the left chart where you see the model evaluation. You have to evaluate your model, that is your model is accurate or not, is your model having the acceptable accuracy or not. Then after, when you get the acceptable accuracy from your model, and then you have to use that model for bringing the output from that model. So that's all comes under the machine learning part. And next we are going to our next topic is supervised techniques. In supervised techniques, it comes under the machine learning. Like uh, I want to say that AI is a big field, artificial intelligence, and in that artificial intelligence domain, machine learning is a subset of that artificial intelligence. And this supervised technique is comes under the machine learning. And along with supervised techniques, there are second topic, which is also known as non-supervised techniques, which all is also comes under the machine learning domain. So if you are trying to make a chart in your brain, like there is a big domain, big circle of for the AI, and then there is a subset of of AI, which is machine learning. That is the small circle inside that big circle. You have the machine learning part, the which is the subset of AI. Then comes the supervised technique, which is also a smaller circle than the circle of machine learning, and it is also a subset of machine learning, or you can say it is a part of machine learning where you have to do supervised where you have to apply this supervised technique. And along with supervised techniques, there is so many parts. We will talk about that parts in later on. So now talk about this supervised techniques. In supervised techniques, you have your training data set, and you have to use that data set to get your arbitrator. Like you have to get your output from that training data set. And for that, you use some machine learning algorithm. So after using the training dataset, you use that dataset for the input in a learning system. Learning system like some machine learning model, and that model is basically, you can say that, supervised techniques. And after using that model, you get your output. So why this technique is called supervised learning? Because we have our input, what kind of input we are providing in our machine learning model, and also we have output. That means from that input, what kind of output we want from that. So as we already know that for this input we want this output, and for this input we want this output, then that's why this techniques is called supervised technique, where we already know the output and we provide that output along with input for the machine learning model to train. So this type of training is known as supervised learning. And after this topic we go to this non-supervised techniques, where we get our data set, and our data set is in the raw format, which is not in the organized format. Then we have to do some operations and organize our data and keep the columns which we want, delete that data which we don't want, and after that we apply some algorithms, machine learning algorithms on that. And here only we have the input, we don't know what kind of output we want from that input data set. So we only give the input to our machine learning algorithm, and after that we do some processing and get the output. And output is in the clustered format. Like if we provide 10 points, 10, like assume a graph, 2D graph, and you have some 10 coordinates, and you provide that 10 coordinates to your machine learning model, and then your machine learning model gives the output. And output is in, like as you see on screen, there are three colors: orange, green and purple, and same in this order you get your output for that 10 coordinates. Like three coordinates are in orange format, and three coordinates are in green format, and four coordinates are in purple format. Like this our machine learning model gives the output and the clustered format. That machine learning model will make the clusters of your 10 coordinates into the three clusters, and that clusters is our output in non-supervised. So here is, output is not defined, and you cannot predict the accuracy of your model because we don't know what is the correct output for this input. But we use this technique to make our data into a cluster format and segregate our data, segregate our raw data into a meaningful order. And further we can use this output, this clustered data set, into the supervised learning. Like when we provide the input raw data set to our machine learning model, this non by using this non-supervised technique, we get our raw data into the clustered format. And after getting the clustered format, we provide that clustered data to the supervised technique, where we know that what is the input and what is the output for that data, and use the further processes on that to make machine learning models, to make the models which were used in real world. So that's all for today's session, and I hope you get to know about these topics: data science, data mining, statistics, machine learning, supervised and non-supervised techniques. Like if you want to came in data science or in the data minings, and if you want to know about statistics, then why you want to know about this statistics and this machine learning. So if you want to came in this domain, like what you have to do and what you have to perform, what are the basic blocks that you have to know. So I hope I clear all these doubts of you.
Introduction to R. What is R? R is the primary statistical programming language for performing modeling graphical tasks. It is used for a variety of tasks that involves complex data sets. A freely available language and environment for statistical computing and graphics, which provides a variety of statistical and graphical techniques such as linear and nonlinear modeling, statistical tests, time series analysis, classification and clustering, etc. So why should we learn R? R is open source language. That means it is easily available programming language. It is a comprehensive statistical platform. It helps in visualizing any large and complex data sets. It provides interactive data analytics. It can easily be integrated into other programming languages, and it can run on any platform such as Windows, Mac, or Linux operating systems. Few domains using R for analysis are finance. So in finance, R is used to make models for downside risk measurements, adjust risk performance, and utilize visualization like candlestick charts, density plots, drawdown plots, etc. In banking system, it is used by the industry for credit risk modeling and analysis and other forms of risk analytics. Then it is used in healthcare also. It is useful to perform pre-clinical trials and analyzing the drug safety data. In social media, it is used for social media analytics for segmenting potential customers and targeting them for selling your product. Then in e-commerce, it helps in analyzing cross-selling products to the customers of the company. There are many other domains also that uses R in today's time for analysis. Some of them I have explained here. Next is why should R be used? So in today's time, R is very important as an analytical tool. R has the overall qualities for a business, the best mix of desirable attributes, including high data science for business capabilities, low cost. It is low cost and open source, which is a very essential quality of R. It is growing very fast and a massive ecosystem for powerful R libraries. Being open source, any you can add your own library to the programming languages. Data R is data science for non-computer scientists. So data tools have two options. You can either use R or you can use Python in the data science. Most people interested in learning data science for business are generally not computer scientists. Most activities involved in business and finance involves communication. So let's talk about Python and R. How are they different? So in Python, Python includes solid libraries for math, statistics, and machine learning. It is best-in-class tools for pure machine learning and deep learning. So it is well suited for computer scientists and software engineers. Wherein the R, if we talk about R, it is an open source libraries for statistics, machine learning, and data science. The depth of topics, specific packages, and its communications infrastructure. It is best-in-class tool for visualization, reporting, and interactivity. It is well suited for scientists, engineers, and business professionals. There is a con to Python that it lacks much of the infrastructure for subjects like econometrics and communication tools such as reported, which can be easily be done in R. Then what all we need for R? The first thing we need is the R and the R Studio. So R is a programming language for statistical computing and graphics. So we will be installing R. Then we will be installing R Studio, which is an integrated development environment for R. So they both are open source and are easily available for Linux, for Windows and Mac operating system. They are available in R is available in 32 and 64 bit, and once you install both of the systems, that is R and R Studio, then you should run it as a administrator. Before installing R Studio, one should install R. So let's start with installing R first. And the link to download R is www.r-project.org. So this is the site where you can get all the data about R, from about the R, why we should use R, introduction to R. You have logos here, all the contributors in the R. You can get the information about them, what's new here, if you are if you came across any bug in the R's application, you can always report it here. So there are different tabs here which you can get help from in any of the way for R. There are manuals, documentations, all the libraries that we will be using in R are available on this website. Then it is the CRAN. So CRAN, it is the Comprehensive R Archive Network. So it is a network of all the web servers around the world that stores identical and up-to-date versions of codes and documentations of R. So you have a link to all the, once you have clicked here on CRAN, like here, so we will be routed to a mirror, CRAN mirrors. So these are the servers, these are the links for the servers that are nearest to the location mentioned above. So whichever location you are in, you can download the R from that link. We will be using this link. Once you are selecting one of these links, you will be directed to this window wherein you can see there is 3 types of option. So download R for Linux, download R for Mac operating system, or for Windows. Here we need it for R. The current version, that the latest version of R that is released on 24th April 2020 is R 4.0.0. Once you will click here, download for R for Windows, you can see there is an option here, a link here which says install R for the first time. Let's click here and you can see the download is available here. Just click on it and it will be downloaded in your location wherever you want to download it. Because I am already I have already installed R, I am not doing it right now. You can just download it and run as administrator, so that it allows you to get all the links available with that. So next is installation of RStudio. So RStudio, as I told you, it is the IDE for the R. So it is a kind of GUI, graphic interface, which is very easy to use. It helps to use. It helps us in using R codes easily. To install R, to install RStudio, the link is it is rstudio.com. So this is the site where you can get RStudio from. Just go to products and we need RStudio IDE for R. So there are 2 versions of RStudio, either for desktop or as a server. So here we are installing it as a desktop, for our desktop. So we will be selecting desktop. If you want it for the organization where multiple people can use one user ID, for that you can use it as a server. Let's click on desktop. So you can see it is giving you the overview of both the types. So I have selected the desktop as a version. So there are 2 types of versions of desktop. So it is open source edition and RStudio Desktop Pro. So the Pro one is the license agreement, for which you will have to pay $995 per year. And if you select open source, it is free of cost. There is no pricing. Then if you are selecting as a server version, so there is again open source, you can use it for free. Then there is a paid version for the Pro version. It is starting at $4,975 per 5 named user per year. So let's go to download RStudio Desktop, which is open source one. Now you can see again it shows me different types of plans. I want free one, that is open source license. Just click on if you go down here, you can see there are links for different operating systems. If you are using Mac operating system, the link to download RStudio is next to it. If you are using Windows 7, 8, 10, then it is this link. Similarly for Ubuntu, Fedora, and OpenSUSE. So you have all the links available to download RStudio for different operating systems. I am using it for Windows, and 1.2.5042, you can see it is the latest version of RStudio. It requires at least R version of 3.0.1. So we have already downloaded our R. If you just click on it, so it is again downloading it. So I have already downloaded it. I am not installing it again. If once installed, run it as administrator, as you must have done it for R. Once you will install R, there will be two icons available to you for R created on the desktop and confirming the installation of R. Let's talk about R Studio now, how to use it. R Studio is an integrated development environment that allows you to interact with R more readily. R Studio is similar to standard R GUI, but it is considerably more user friendly. So initially, so this is how your R Studio will look like. But initially, when you open it, initially when you will open R Studio, it comprises of three windows. So first window is the console window. Next will be the environment and history window, and last will be the file, plot, package, and help window. To open the fourth window, it will be the source or the script window. So let's go to R and let's see. So here you can see this is the first window we were talking about. It is the console area. Then this part here is the, so here it is the console area, it is the environment and history area, and this is the file, plot, and package area. So as you can see, my packages of my R version is a old version. I installed it earlier. I will have to update it. So if you want to update R Studio and R version, you will have to download it again, going to the same link that we used initially to download our R. Once you have installed it again, you will be seeing the new version name here. So let's get introduction of R Studio. First thing is, whenever you are starting a R Studio, you will need a project. So you should always create a folder for R, wherein your all the projects will be saved. Like I am using R code here. The project that I am using is R code. You can always create a new project. Then you can go to new directory and new project. So you will be mentioning a name here. So you can mention any name, like if you are starting your R, you can say R file. So just browse it where you want to save this subdirectory and create project, and you will be switched to that new project once you have created that. So you can see I have created a new project here with name R file, within which only one file is, it is the default file that will be saved to your folder of this project. Then this file area here, what does it show? It will show you all the files that will be included or created in your project. Then there is plot. Whenever you will be building a new plot, it will be showing up here. It will automatically open this window, or will automatically open this window whenever you were running that command to build a plot. Then the package, each and every package that you will be installing, it will be saved here in the libraries wherein your R is saved. You can install a package using this tab install. You can write a package name here, like if the package is this, you will get a list of package. You can write that name and just press install. If you want to update it, you can click update here. Your packages will be updated. Packrat, this option will help you to create a new package from your site to the CRAN. It should be up to the policies of CRAN in order to update a new package. Then there is help. So help provides you with any of the function, or if you want any information regarding a function or a package, you can always just question mark here and write any of the functions. Like if I want mean, to know what is mean, so you can see help is provided from R, that mean is the generic function for the arithmetic mean. So this is kind of help. It will provide you with the function that you can use in R. It will give you examples also, so that you can get a full knowledge about arithmetic mean in R. Then there is viewer. Viewer, it is a web browser inside our studio. It is generally used for Java or HTML scripts. Then there is environment. Environment here, it helps to environment. It is the area where the variable or whichever command you will be uh, telling in typing in your console or script area, it will be saved in environment. So it is for the current session you are doing. And history, it will save all the previous old commands that you have executed from console or the script area. It will save each and every command that you have mentioned. Then connections help you to it is used to connect R to other database servers like SQL server or MS Access server or Hadoop server. You can connect the servers with R Studio here. Then there is console and there is a script. So how do we open this fourth window? You can either go to file and new file R script. The keyboard shortcut is Control Shift N, or there is a button here. You can see that we need to add a new R script. So you can see a new window has been opened up here. So this is the script area and this is the console. You can either write your code in the console or in script. Once you are writing a code here, suppose I said save value 1 in X. So whenever you want to execute a command, just control and enter. The output will be shown on console. You can also write a command on console, then also it will be saved. How can you see these variables are saved? You can check environment here and you can see there are two variables that we just created, one from the script area and one from the console area. So this is environment, and history will show you all the commands in that session and from the previous session also. If you want to save this file, there is a save button here. It will save your current document, and if there are multiple files open, you can always use Control Alt S or press this button to save all the open documents. Then the other things that you should know about R Studio are in the code area. You can see there are shortcuts, keyboard shortcuts that you can use, like if you want to comment a line. So what is comment or uncomment a line? You can select Control Shift C to comment that line. Suppose you do not want to run this code, you have a error, or it is telling you about that line, like suppose to comment that, you just put a hash sign before it and you can write about it, like creating a variable. So it will not run this part. Or if like I comment this part, like I wanted C equal to 3, I do not want to execute this command, I can just comment it. It will not, R will not run this command. There will be, you can see in the environment, no C variable has been created wherein the 3 value is saved. So because we have commented it. So this is how there are different shortcuts you can always use in R Studio. View also tells us about different panes and different tabs that you can switch to using keyboard shortcuts. Then there is an option called panes here. So this is the first pane, second pane, third pane, and the fourth pane. If you want to change the layout of these pane, you can always use view here and go to panes, and there is an option show all panes. In this case, all the panes are visible. If you say console on left, so you can see our console area is on left. If you want your console to be in the parallel in the right side, just click it and you can see our console has been shifted to the right side. Then there is plots, sessions. Whenever if your R is not responding, if there is any error or your codes are not running properly, either you can restart R here. So restart will not change your codes, or it will not close your files at that current session. It will just restart your R, but you will have to run your codes again. or you can terminate our session, wherein your session will be terminated and you will have to start again. You can set your directory, like if there is any project, different project, you can go to that directory from here. And if you want a new session to be started all the way along, then you can click new session. Then there is tools. So now this is important thing that I am telling you. Here you can use install packages from here also. If there is any package update, you can check here. Then there is this global options. Just go to global options. Then there is general commands. These are the setups that you can do to your R Studio. Just go to code here, and you should always select soft wrap for your source files. What does this soft wrap do? If your code is lengthy, if it is very long code, if you and you have not tick marked it here, it will it will look messy. It will be not available in the whole area of this script area. But if you soft wrap your R files, what will happen is it will come to the next line automatically once it reaches the end of your pane. So it is helps you to look make your outlook of R better. Then there is appearance. So you can always change the appearance of your R. Like I have selected Lucida console here. What you can choose different type of layout for your R Studio. Like if I use generally in today's time, people using black layouts, dark layouts, that I mean to say, because more it is more soothing to your eyes. Like if you want a white background, you can use this kind of layouts wherein your background is of white. If I apply this, so you can see all of my layout has been changed to white. Let me select my previous one. So I'm not applying this layout. Let's change it. So, and then there is help. So help is also very essential to understand. So if you want any of the help regarding R, you can just click here. About R Studio, you can check here. If there is any update of R, you can just check. It will give you a window wherein you can see R Studio. This is now available. I am using a previous one. So just you can either do it right now or just say remind me later. Then there is cheat sheets. So cheat sheets are very important. There is option to browse cheat sheets also. It will take you to a URL where you can download each of the cheat sheet. Cheat sheets are having functions for that package that will help you to understand a whole of the package involved in that cheat sheet. So this is all about R Studio. We'll go ahead and write different codes and study different techniques involved in R. Importing and exporting data in R. There are a number of ways for importing the data into the R. Some of the formats we can use are through CSV file, through text file, through a web URL, a Excel sheet or a Google sheet. So let's start making data in R. First, we are using CSV file format. CSV stands for comma separated values, and it is used to store the data in a tabular form. The command that we use for CSV file is read.csv. Let's go to R. First, let's make a sheet in CSV format. I'm using Microsoft Excel for that. What we can do is we can create the data that I have created here. I have taken roll numbers, name, age, and gender. I have taken 10 roll numbers, 10 names, 10 age, their age, and their genders. So I am saving this data as a CSV format. So how can we save this? We can go to save as, and wherever you want to save the file, save as type should be CSV, that is comma delimited format, and you can save this file. The file should be there in the folder in which your codes are there, where you are saving your all the files, so that it can pick up your file easily. So what I'm doing is I'm creating a variable x. My function to read CSV file is read.csv. Within brackets, I am typing the name of the file, that is test.csv. You can check, I have a file name here named test.csv. I am taking header as false. What is header as false or true? It means whenever you are giving a value or a data to R, it will automatically convert it into tabular form. But if you are making header false, it means it will not take your headings as a heading value and it will be taken as a normal observation. You can see I have executed the command. Now let's check the value in this variable, that is x. So what it has done is it has taken roll number as a sequence of that vector. So it has created vector 1, vector 2, vector 3 and vector 4, and roll number is a part of that vector. It is not a heading because I have selected header as false. Similarly, we can do header equal to true. So what will be the change? Let me show you. I am executing this command, that is read.csv within brackets and inverted commas the file name, and header is true. So in this case my headings will be shown as first labels and not as plain text. Let me print the values of j. So you can see now roll number, name, age and gender are my headings here and others are my observations. So it is very easy to import a CSV file into R. There is one more way you can import the data. The next way to import the file is URL file. So what we are doing is whenever we are getting a URL or a online web link, it should be in CSV format in order to import it into R, and the command for that is to read that file is read.table. It is the main function to read that URL and it will convert, what will happen is it will convert your CSV format into a tabular format. So let's go to R and check the data. So what we are doing is there is a link I have here. It is the all the local radio stations and their details available publicly. It is in CSV format. Now what I am doing is I am saving this URL in a vector, in a variable ABC. So in ABC within inverted commas I am saving this file. Now I'll read it. How do I read that CSV file into R? I am making a variable radio is equal to read.table is my command within brackets. First thing that I am doing is ABC, that is this vector. I am giving this vector the file which I want to read. Next is header. It should be true so that all the headings are taken in their original form. Separator, all the files are in separated, all the columns and values are separated by commas, and string as factor as false. So what is string as factors? Strings as factors do not convert every or the categorical values into factors. That is a categorical format. It will keep all the vectors in their original data type. So I am going to run this command. I have saved it in ABC. Then there is radio variable. I have executed my command. Now what I am doing is I am viewing this radio variable. Now what happened is there is one more tab here with name radio. So what we have done is we have created this variable radio. In order to view it in a Excel kind of format or rows and column format, the command is view with a capital V. There should be capital V, view within brackets name of the variable. What it will do is it will show you the data in the form of rows and columns. So you can see column 1 is of state, next is their URL of every radio station, name of the station, their town and so on. You can see it is a very big file. You can also, like I have in earlier case I have read this file that was test.csv. You can see I have saved it in my files. You can check it here. I can click this here and view file. What it will do is I can see that as it is a CSV file, so it is separated by commas and it is not in the form of table, because in this we have given read.csv. But in this file, when we are importing the data through URL, we have taken the function read.table, which what it is happening is my data is converted into tabular form. So it is very easy to import the data. Next is text file. So what is a text file? The extension always ends with txt, that is a simple format, and text file are the plain text that we can enter in any form, like it is in Word or any of the format. We can also create it through Excel files. Like I'll show you how can we save a Excel file to a text file. We can also create it in R also. And the function that we use in R is read.table, similar to the URL one. It will convert the data into tabular form. Let's go to R. First, let's go to Excel. I'll show you how to save the file as a text file. So I have created this file. It is the same file which I have saved as CSV. Now I am saving it as a text file. So what we can do is we can go to save as, and in save as type it should be a text MS-DOS. I am not taking it as Macintosh. I am taking it as MS-DOS here and saving the file. I have already saved it, so I am not repeating it again. You can see I have saved the file as test.txt. If I view this, so what happens is it is showing a plain text. There is tabs here. There are gap of tabs. It is tab separated file. How to read this file in a tabular form? So what you can do is the command similar to the first one. It is read.table. Within the brackets, it's test.txt. I'm running this command. I'm sorry, I have selected the wrong one. So what I am doing is I'm executing the command and printing the values. So now what happened when we are executing when we are reading a CSV file, like earlier when we read here, if we do not take header as false here, what will happen is by default it is true. By default header is taken as true in read.csv format, but when we are doing read.table, it will take it as plain text and not as a heading. So for that what we will have to do is we'll have to make header equal to true. We will have to give that command. As you can see, when it was not taken, there were four vectors created, and roll number, name, age were taken as an observation and not as headings. In next command, what I have done is I have given header equal to true. Now let's print the values. Now you can see each of the heading is correctly placed on their heading place and are not taken as observations. You can also import the data from this pane where we have environment. And what is environment? Actually, environment helps you to check all the variables that you have created. It will be saved in that environment. So what you can do is go to import dataset, and from text, so there are different types of ways you can import the data. One of them is text. So you can take a file, whichever is your text file. So you can just go and open it, and it will, you can see what they have done is you are imputing this file and data frame will be created in this format. Okay, so I have already imported the file. I'm not doing it again. I'm just showing it to you. You can do string as factor as check marked, or you can remove it. Next is Excel file. So Excel file, in today's time, most of our data is generally created in either Excel sheets or Google Sheets. So what happens is you cannot do large analysis in Excel files or Google files. For that, R is very helpful, and it is very easy to import the data from Excel files. And the command that we are using is read.xlsx, and this command is in the package name as xlsx that we will be installing. So what you can do is, as I have already told you how to install the package. So in either you can go to packages and install the package from here by typing the name of the package, that is xlsx, and install, or you can type the command, that is install.package. I have already installed this file, so I am not installing it again, but you will always have to load the package before you want to use function of that package. So for that, I am executing the command library xlsx. Now what happened is my package is loaded in my session. I am creating a variable excel here, and the command I am using is read.xlsx. So what I'm doing is I'm reading a Excel file. The file name that is test1. I have already saved this file as Excel file. You can see here in the files I have already saved it. And after that, the comma, the next tab is sheet index. So sheet index, what does it tell? There are multiple sheet in Excel files. You can create multiple sheets and you can specify the number for that. So I want only first sheets values here to be read. So I'm taking one here and I'm executing this command. Now let's run this Excel sheet, and you can see my values are saved in this. I have taken very small data set here. There can be n number of rows and columns. It will be very easy for you to run this command and load that data into R and do further analysis for that. What you can also do is, sometimes what happens, there are so many sheets and you have given a sheet name to the file. The command you can use here is like I have given sheet index as 1, and also I have mentioned the name of that sheet. Suppose I have given the name of the sheet at data underscore t. So you can mention the name so that it can be easily loaded and there is no confusion. Also, what you can do is, if you don't want to write big formula, big function, you can remove sheet index and you can simply type 2 or 1, whatever your sheet number is, you can type here and it will automatically load that sheet in R. So what are the other formats? You can also import the data through Excel. Similar, like we have imported the data of text file. I'm going to import data in environment, and we can select from Excel here. So you will have to give the file URL. So how can you browse that? Just browse. I have easily got my names of the sheets. I have here Microsoft worksheet that I want. I will open it. Now you can see I have URL and the data preview. You can specify the sheet number that you want. I have only one sheet here, so it is not showing other file names. But if there were multiple sheets in that Excel file, it would have shown. You can give the range from which cell to which cell you want the data to be taken, and you can import it. So you can see it has imported into our data set. Next, the last way we are importing the data is Google Sheets. Google Sheets are used in today's time in very much. It is very useful and it is very helpful, as multiple people can collaborate the data into it at the same time across the locations. So we can directly import the data from Google Sheets using the package G Sheets. We can install the package and use its functions, but there is a can say disadvantage of using G Sheets, that you have to make your file publicly available. So sometimes it becomes a issue. So let's go to R and run the codes. So for using G Sheet, the library I'm using is G Sheet, and you can similarly install the package from packages, either from packages, or you can give the command install.package G Sheet. I am loading the package into my session. Now, how will you create this file? What we will do is we'll create a file on Google Sheet. So what we are doing is we are creating a Google Sheet. It is the simplest way. Like, we go to Google Drive, add a sheet, and I have taken same values: roll number, name, age, gender. Now what we will do is, there is an option here, share, with whom you want to share the file. So what we'll do is go to advanced, and you can see anyone with this link has been chosen here. So what you have to do is you have to choose public on the web, so that anyone on the internet can access this and they do not require any sign in for that. So I'm selecting the file, save it, and done. Now what we'll do is we'll take the URL from this and we are going to paste it here. So what I'm doing is I'm creating a variable with this file name and I'll save it. Now what I'm next step is I'm using a function from this G-sheet package, and the name of the function is as.data.frame. So what it is saying is I want to create a data values in the form of data frame. It is a data structure type. Within the brackets, I'm saying G sheet to TBL, that is table. So I'm converting a G sheet into a table format, and I'm giving the URL value here. So let's run this command. Now let's check the data ABC. So you can see what we have done is we have created a Google Sheet on online. Now we have that values, that data into R easily through the use of package called G-Sheet. Operators in R. There are four types of operators that are used in R. They are assignment operator, arithmetic operator, relational operator, and logical operator. So let's start with assignment operators. Assignment operators are used to assign a value to variable. It can be a leftward operator or a rightward operator. Both result in same way. As you can see in example, I want to save the value 10 in variable h. For that I am using leftward operator by using less than sign and a hyphen sign. It creates a kind of arrow towards left, which means the value of 10 has to be saved in variable h. Similarly, you can use double less than sign and then hyphen, and equal to sign will also operate in same way. Similarly, there is rightward operators where hyphen and greater than sign, hyphen and double greater than sign. So let's go to R and let's execute the command. First, we'll create 5 kinds of variables, and then we'll execute and see what are the results. First, I am creating a variable h. I am using leftward assignment operator using less than sign with a hyphen and saving the value 10. Similarly, you can see next operator is double less than sign with a hyphen, and next is equal to sign. So you can see I have used 3 kinds of leftward assignment operators here in the console, and if I print the value, you will get the same result for all the commands. And if you use a rightward operator, so I am using a less hyphen sign with a less greater than sign. What it will do is it will save the value 13 in variable k. So it is same way if any ways either leftward or rightward, it will print the value that are saved in that variable. You can see either leftward or rightward, the value is saved in variable. Next operator is arithmetic operator. So arithmetic operators are used for basic mathematical operations such as addition, subtraction, multiplication, division, or you can use them for exponent values, modulus, integer division. So let's go to R and one by one execute each of the commands. So I am having 2 variables here, that is x and y, and I have saved value 5 in x, and in variable y it is 2. Print those values. So you can see I have created both the variables. If you want to check their values, you can print their variable also. So you can see x is with 5 value and y is of 2 value. Now let's add x and y. So I am using plus sign here as a arithmetic operator for addition. Let's execute this command. So you can see 5 plus 2 is 7. So it helps in addition. Next, it is subtraction. For subtraction, as we use in mathematics also, it is minus sign. Let's execute this command and you can see x minus y, that is x is 5 and y is 2. So the remainder it comes is 3. Next is multiplication. For multiplication, we use a star sign. For multiplication, let's execute the command and you can see 5 into 10, that x into y, that is 5 into 2 is 10. Next is division. For division, the operator that is used is a slash, and you can see the value that prints is 2.5, that is 5 divided by 2, which is 2.5. Next is exponent. So exponent, what does exponent means is kind of raised to the power, like we use 5 raised to the power 2. Here I am saying x raised to the power y. It will multiplicate 5 twice, like 5 into 5. So it is 25. Next is modular sign, which is which symbol is 2 times percentage sign. What it does is it results in the remainder value when you divide. So it gives the remainder value What we will do is x modulus y, which means 5 will be divided by 2 and remainder should be 1. So let's execute this command and you can see my remainder is 1 here. Similarly, next is integer division. What is integer division? It helps us in the result with quotient. Quotient, like if I am dividing 5 with 2, so 2 into 2 is 4 and the remainder will be 1. So 2 is the quotient here and result of x integer division by y should be 2. So you can see this is how all the arithmetic operators are used. Next operator is relational operator. So relational operators help to compare or find a relationship between two entities. They always return values in the form of true and false. For relational operator, we use less than, greater than, less than or equal to, greater than or equal to or not equal to signs to make a relationship between two entities. Let's go to R and create some commands. So I'm taking two variables here, A and B, having values 5 and 9. Now we'll compare them and we'll create a relationship between them. So let's start with less than sign. A is less than B. It is a general mathematic formation that we also use. So let's execute it. So you can see the value that returns is true. What does it mean? My A value was 5, B value was 9. So A less than B, that is true. Next, if A is greater than B, let's execute this. So the value result is false because B value, that is 9, is greater than 5. Next, if A is less than or equal to B, so it should be true because 5 is less than B, that is 9. If A is greater than equal to B, so it is false. Next, A equal to B. So what does it mean? If the value of whichever value is saved in A variable, is it equal to B? So it is false here. If I would have taken 5 in both of the variables, it would have resulted in true value here. Next is if A is not equal to B. So it should come out to be true because both the variables are having different values. Next is last is logical operator. Logical operators help to make a decision based on multiple conditions that can be evaluated to a true or false result. So logical operators helps to find out if two vectors or two variables, if they are equal or if they're the values in those vectors or variable match or not. So let's go to R and create some vector and variables. So I'm taking a variable here f equal to 14. So there are four kinds of logical operator we are using, that is logical not, then there is element wise logical and, logical or, element wise logical or, and there will be a logical and also. Let's go one by one. So I have created a variable here f with the value 14. If you want to check it, its value is 14. You can see. Next, we are using AND operator first. So AND operator, I'm giving a condition. So logical operators help us to find out values, compare them using different multiple conditions applied to them. So like first, that is f greater than equal to 5 and f less than 15. So what does it mean? If the value of f variable is greater than 5 and less than 15, and means it should be between it. Let's execute this command and the value returns is true. So what does it mean? My 14 lies between 5 and 15, which is actually true. If I change the condition, when I am saying f greater than 5 and f greater than 15, so it have to be false because f is less than 15. Next is OR operator. We'll be using same variable for that. If I say f less than 5 or f greater than 15, so it will come out to be true. It will come out to be false. So it will come out to be false because we are using OR operator here, which means one of the conditions should be satisfied. So we can see f less than 5 and f greater than 15, they both are not satisfied in this condition. So the value that returns is false. Next is f greater than 5 or f greater than 15. Now in this condition it should be true. So how do we know that? Because f is it is not less than 15 but it is greater than 5. So this condition returns a true value. How does it do that? because we are saying either f should be greater than 5 or f should be greater than 15. In our condition, f is greater than 5, so the value returned is true. One of the conditions should be true to have the true value here. Next is or operator. Not operator. Not operator, what does it help with? It is the opposite of the value we are entering into a variable or our condition. For example, if we say f is less than 5, we can also write it as not f less than 5. Let's print this. If we say f not less than 5, so as we know, f is not less than 5 here. It is the value of f is 14, but we have used a not operator here, which means it will give a opposite value of the condition. That is why we are getting the value true here. If we directly print this command, it will be false, which is the correct result, because f is not less than 5. But if you are using a not operator before it will reverse your result. For example, one more example we can take is dot numeric. So what we are doing is 5 is a numeric value, we know that, and we are questioning if this value is numeric or not. So if is dot numeric, let's execute. So it is true because f is a numeric value, 5 is a numeric value. But if we put a not operator in before using this command, it will give a false in return, because it reverses the command. With not operator reverses the command, so it will become the opposite of the earlier command. Let's also try it on vectors. So we are using and or not operator with vectors. So I have taken two vectors here, one with true true false value and true false false. Now what we will do is we'll compare them and using and command. Now let's compare two vectors using and double or conditions. We'll be comparing both of the vectors, every element of the vectors, and also using double and double and or operators to check element wise comparing the vectors. So first the two vectors are true true false and true false false. Using and command, what we are doing is we are comparing both of the vectors element wise and will be resulting for each of the element. Let's execute this command. So there is true false false. The result that came is by comparing first element of each vector, that is true and true. So the first result is true. Next is next element was true and false. So if both were true, the result would have been true here. So one of them is false, therefore the result is false. And next both are false, therefore the result came out as false. So we compared each of the elements of both of the vectors. Next, if we are using same vectors with a or operator here, now they will take the elements for having at least one of the conditions. So if I am having true and true here, the result should be true. Next, true and false means the result that will came out will be true here, because one of them is true. And both are false, it means the result will be false. Let's execute this command and check the output. So you can see both were, as both first elements were true, so the result is true. Next, same way, one of them is true, so the result is true. And both are false, so false. Now if we are using not command in before using the vector, here just I have printed the value. Let's print this value. So the result is false true true. So what happened is the not command reversed the values of the vector. Therefore the value which was true became false and the value which were false became true in the result. Next we will be doing element wise. When we are using and command, what it does is it compares only the first element of each vector. If we print this vector result, it will be true. What does it mean? Both of the first elements were true, so the result came out to be true. Similarly, if we are using two or here, so the result will be true. If I would have taken false here, now let's check this command. Then also it came out to be true, because or operator, what does it say is one of the conditions should be satisfied. So if it in the second vector the first element was false, but in the first vector it was true, So my result is true here. So let's sum up the video and check what are the operators that we have covered. So there were four types of operators. There were assignment operator, arithmetic operator, logical and relational operators. In assignment operators, we use two operators. They were leftward assignment operator and rightward assignment operator. So when we were using leftward, there were less than hyphen, two less than hyphen, or equal to sign. For rightward, it is hyphen and a greater than sign. So it actually creates an arrow towards right or an arrow towards left. Next operator that we used was arithmetic operator. Arithmetic operator helps in mathematical formulas, simple formulas like addition, subtraction, multiplication, division, exponent, modulus, and integer division. Next we covered is relational operators. So relational operators were when we were creating relationship between two elements and resulting in the form of true or false. So they were less than, greater than, less than or equal to, greater than or equal to or not equal to sign. And last we use is logical operator. So logical operators, and they help us find our output using multiple conditions, using logical not or logical and operator, element wise logical and operator, that was we are using two times and sign, logical or element wise logical or, where we compare first elements of the vector or any of the matrix that we are using, and the outcome is in the form of true and false. In this video, we are going to discuss about data types and data structures in R. So let's start with discussing what is data type. Data type of a value is an attribute that tells about the kind of data that value can have. So it is simply means they are the characteristics of the data we are using in our software program or any language that we are using. There are different kinds of data types in R. First is character. So character means a letter form, alphabetical form, in which it can be a single letter or a group of letters. Like A, you can store a, or a group of letters like data signs, or name, address, it can be anything. Numeric data type means it can be a whole number, it can be a fraction, decimal, any part. Integers, they are the whole numbers or non-fractional values like 4, 6, 8. In our language, we add an capital L to that integer number so that it can be saved in the form of integer. Next is logical. Logical data type means is the value true or false. Complex data type means it is a combination of real and imaginary part, that there should be a number along with any of the alphabet or a imaginary part. Next are data structures. So data structures are very important in any language. Data structure is a storage format that enables efficient access or modification of the data. There are different kinds of data structures that we use in R. First is vector, second is matrices, arrays, list, and data frames. So let's start with vectors. Vectors are the simplest form of data structures. It is a series of data elements. They are combined in the form of a sequence. A vector should be in only one data type, either numeric, integer, character, or logical or complex. So let's go to R and start writing the codes. I have already written the codes to save the time. So let's start with numeric vector. So I'm saving the value in X variable. I am creating a variable X where I'll be saving values 2, 3 and 4. Here C means that I am combining these letters, these numbers, and forming a vector. So let's create this variable. After execution, I can check the value in the X. So I'll simply put X here and control enter. So you can see the value that I have stored in vector X is 2, 3 and 4. Now function to check the class of that vector. It is class, and in the bracket parenthesis it is X, the name of that vector. So it is numeric, as we can see. Next is length. Length shows the how long is that vector, how many values are there in that vector. So we can see there are 3 values in this vector. Similarly, it can be in character data type. Whenever we are creating a vector with a character data type, it should be in, whenever we are creating a character vector, so here I am saving my characters in a variable Y. I am combining A, B and C, and whenever we save a character, it should be in inverted commas so that it can be saved in the form of character. I have entered the value. Now let's check the value of y variable, and we can see a, b and c are saved in y variable. Now let's check the class of y. So we can see it is in the form of character. These variables are stored in the form of character. Similarly, we can create a logical vector. Same way, entering the values of true and false, integers. So here you can see that for saving integers, I have added a capital L to the value. Now let's check the class of this variable. So you can see it is saved in the form of integers. Now next is adding an element to the vector. Now I have already created a vector of the character. You can see here it is y. Y variable was in character vector, and now we are adding an element to that vector. What we will do is, in same variable we are adding d in it. So first we will give the same variable name, comma, the element that you want to add. So let's execute this command. So I have given in y variable I want to add d. Now let's check y variable. So you have seen that earlier there were a, b, c. Now there are a, b, c and d. Another way to create a vector is you can directly give a variable name, like I have given here is series, and I have given 1:10. It means that I want to save vector from 1 to 10 value. Let me just print this value and writing the name of the variable and control plus enter. You can see I have created a vector from 1 to 10. We can also check the class of this variable. So you can see, let's print the value of series variable, and you can see there are 1 to 10 saved in this variable. Similarly, there is a command called seq, that is sequence, and I am giving in the brackets number 10. So it means I want to create a sequence with values 1 to 10. It automatically prints it because I have not saved it in any variable, so it is directly printing the values from 1 to 10. Next, what I am doing is I am creating a sequence starting with 1, ending with 10, and with an interval of 1.5. So let's print this value, and you can see there is 1, and after that there is 2.5, 4, 5.5. So there is a gap of 1.5 after each number. Let's go back to the next is matrix. Matrix, it's a collection of elements. So there are fixed number of rows and columns. So it means it is a two-dimensional data structure but there should be only one data type in whole matrix. It means the rows and columns should be either in numeric form or character or logical or any other, but only one data type. Now let's create matrix. So the command to create a matrix is we give matrix, and within brackets we first provide the data, like what from where to which end you want that the values to be saved in that matrix. You give the number of rows and columns, and you give the value by the logical value, that is, if you want your values to be filled by rows, so it should be true. If you want them to be filled in columns first, so it should be true. It should be false. Then you can give the dimension names, that is, you can give the names of the row and columns. So I am creating a matrix here, and I am saving the matrix in variable m. My command is matrix, and I am giving values 1 to 10, where there should be 2 columns, 2 rows and 5 columns. So how do I decide how many columns and how many rows should be there? So you can see I have 10 values, and it should be in the multiple only. Otherwise, it will give you an error that rows and column combination is not there. Now let's print this value. So you can see there are 2 rows and 5 columns with the numbers values from 1 to 10. So I'm checking the dimensions. To check the dimensions of matrix, the formula and the command is dim, that is dimension, within brackets name of the variable. So you can see it gives the row and columns. First one is the row, second one is the column. In second command, what I am doing is I am providing the number, the values to be filled in matrix. Then I have given the rows number. Column, it will take by default, like I have given 3 rows, there are 6 numbers, So 2 3s are 6. It can go that ways. By rows, I have done true. So it means the values will be filled by row first. Then there is dim names, that is dimension names. So whenever you are giving the values, the names of the dimension directly, it should be in the form of list. Like command should be dim name equal to list, combining first are the names of rows, then there is name of columns. Let's execute this command, and you can see what I have done is I have given the brackets first, and in the end it will directly print that command. So I have given the names, the row name as DEF and column names as B, A and B. So in first command, in this command I have done filling by rows. So I have given true here. Now I want to fill my matrix column wise. So what I am doing is by row is false. Now let's print this. So you can see the values have changed. Earlier what I have given was in rows equal to 3 and by row true. So what was the structure of the matrix? There were 3 rows and 2 columns, but when I did false, it becomes 3. The other way to construct matrix is we can create a variable, like I have created m here, and I have saved the values from 1 to 10 in it. Then when we check the dimensions of m, there is nothing there. Like if I check the dimension of m here, it will be nothing. So I want to give a dimension to that variable having 1 to 10 values. What I am doing is I am giving, there should be 5 rows and 2 columns. And now let's check the value of m. So what happened is I created a variable m, then I gave the dimensions to it, like I want 5 rows and 2 columns, and when I print it, the variable, what it does, it divides the value 1 to 10 into 5 rows and 2 columns. Now, if we want to add a column to a matrix, to combine a column, the command is cbind. So what I have done is I have created a variable with values 7, 8, 9. Here, let's check here what we made. So I created a matrix, my matrix here, with values 1 to 6 having 3 rows, and I filled those values by column. Now I want to add a column to it with values 7, 8, 9. So what I am doing is I am creating a new matrix and giving the command cbind. So what does it mean, column bind? So I am giving my matrix name first, and then I am giving the name of my variable having new values. Let's execute this command, and I'm printing the value of matrix. It is my matrix 1, and let's print it. Okay, so I have not executed the value of C here, so that's why there was an error. Now you can see there are 1 2 3 4 5 6 from the earlier matrix, and I have added the value from this command C, 7 8 9. Now because I have not given here the values earlier, name of the dimensions, let's print this again. And you can see I have all the dimension names also. If you understand, what I have done is I have given the dimensions name here. I have given the values 1 to 6 by row, 3 rows by rows, dimension names DEF and column name AB. Now I want to add a C column to it. So I have added C here with the help of cbind. Next, if you want to add a row to this matrix, what you will do is you will create a variable, like I have created G here, and the values are 10, 11, 12. Now what I am doing is again I am creating a different matrix, like my matrix 2, and the command for this is rbind, that is row bind. So for column we were using cbind, to add a row we are using row rbind. Again, giving the name of my matrix, I'm using the new one where I have already added a new column, and so my matrix 1 comma the name of my new row. So let's execute these commands. So you can see, so my matrix name was my matrix 2. So there are 4 rows now and 3 columns. As you can see, we have added an extra row, an extra column to my earlier matrix. Next is lists. So if we talk about lists, List contains different data types. It is a combination where we can use numbers, string, vectors. What happens is when we create a list, the vectors or matrices stay in their original data type, but when we execute the command of list, they gives the output in the form of a list. Let me explain this. What I am doing is I am creating three vectors here, and what we will do is we will create a list from those vectors. All three are of different type. Like my first vector, that is v1, it is a numeric vector from values 1 to 5. My second vector, what is the command here is month dot abbreviation, that ABB is abbreviation, and I want from 4th month to 10th month. Let's execute this command. So what we have done is we have saved April, May, June, July, August, September, October in my vector 2. My third vector is a logical vector. So what you can do whenever you are saving the value of a logical, it can be a capital T, or you can type hold true, just F, or a false. Now what we are doing is we are converting these vectors into a list form. So before giving the command of list, let's check the class of these vectors. So I'm checking the class of v1. So you can see it is in the form of integers. Next class of v2, it is in the form of vectors. You can see we have saved April, May, June, July. Next vector 3 was there, which was a logical vector. So let's check the class of this vector. So you can see it is in the form of logical. What we have done in this command, what we have done is we have combined them. We have combined all the vectors with the command is C. C means here you can call it as combine, or it is a concatenate command. What it does is it combine all the vectors. Now if we check the values of this variable combined v, what we have done is we have combined v1, then v2, and then v3. So it is in the form of vector. If we want to check the class of this, so it is in the form of vector. What it does is it combines all the vectors and converts it into character data type. But we do not want that. We want that each vector should be in its own data type, but we need it in a form of list. So the command is we are saving the we are taking the variable list1, and command is list, list, and within brackets we are giving all name of all the variables. Let's execute this command and print the values. Okay, so I am typing, I was typing wrong here. So you can see what it has done is my first vector was 1 to 5. So first it gives the numeric type, then it is giving the character data type, and then it is a logical data type. So what list helps us is with list help in joining the vectors with keeping the original data type of every vector. Next is array. So what are arrays? Arrays, they store the data in more than two dimensional. So what we are adding to our matrix form, like matrix was only one data type but of two dimension, rows and columns. Here we are giving three dimensions to it. Like if we are giving 2, 3 and 4, 2, 3 and 4, what it is means is it will give you four matrices with 2 rows and 3 columns each. So let's create an array. What is the formula command to create an array is within brackets. Starting with array command, within brackets, first you give the vectors or column names. After that, the vector names, that means the value you want your array to have. Next, there is dimension length. So you are giving the dimension, that is rows, columns, and how many matrices you want. Then you are giving the dimension names, that is the name of the rows, name of the columns, and the matrix names. So you can see I have created two vectors. They are in the numeric form. I have created vector 1 with 5, 9, 3, vector 2 with 10, 11, 12, 13, 14. Let's execute these two vectors. Now I have given the names of the columns, call 1, call 2 and call 3. It is a character data type. Again, there is row names, row 1, row 2, row 3. Again, it is character data type, and similarly matrix name. Now what we are doing is we are creating an array out of this data. I have saved that value in result variable. I have given the command array, combining everything inside this. So what I am doing is, first let's combine the two vectors, that are vector 1 and vector 2. Out of these two vector values, I am giving the dimension that I want 3 columns, 3 rows, and 2 matrices, and I am giving the dimension names. Whenever you are providing the names, so it is in the form of lists. So the formula will start with list. Within bracket, you are first giving row names. As you can see in dimension, it is first row, so you should give row names first, then it should be column names, because in dimension the second part is of column, and last are matrix part, so we are giving the matrix name. I am executing the commands here. So I have printed the value of column, row, matrix, and now I am creating an array, and let's print the value. So you can see I have the output of this command. I wanted the values from vector 1 and vector 2. As you can see, it is the same values, but we have two matrices with same column names. So it is a three-dimensional data structure wherein we have rows, columns, and a list. Now let's start with last data structure, that is data frame. Data frame is the most important and mostly used data structure. It is similar to the Excel sheet format. The way an Excel sheet contains the value of different data types, whether it is a numerical data type, character, logical, or any other data type, but it is stored in the form of rows and columns only. There can be different data type, as I told you. So let's create a data frame. The simplest way to create a data frame is the command to create a data frame is data.frame. And what we do is, it is, so when we create a data frame, as we see in Excel sheet, there are different columns, different rows with different data types. So what we'll give the command is data.frame, that we want to create a data frame. Within the brackets, it is the simplest and the easiest way to create a data frame. So what I am doing is, first I am providing the vectors inside the command. So I want two columns here. One is of name and other is of age. So I am giving my first vector as name, within which I have given three names, S1, S2, and S3. It is in the character data type. Next, column is of age. The age is 22, 23, 24 respectively for the names given before that. So now let's print the value of this data frame, and I'll explain how it is created. So as you can see, so what is the difference between a matrix and a data frame is major difference. Matrix is in the form of only one data type, like if it should be only numeric or only character type. But when you are creating a data frame, it can contain different data types into it. Like I have first given this vector for a character vector, next was a numeric data type vector. Now let's create one more data frame. In this, what I am doing is, I am creating a data frame for a class. Like there are roll numbers from 1 to 10. I have created this vector. Then there is a vector for the name. So what I have done here is, I have saved the variable name as name, and the command I am using is paste. So what it will do is, it will paste s uh, 10 times. Like I have given the values from 1 to 10, and it will be separated by a space. So what will be the result is, I am pasting s 10 times with value of 1 to 10, having a space between them. Let's see how it gives the output. So you can see there is s1, s2, s3. So it has pasted 10 times with the values 1 to 10. Next is age. So what I have done in this command is, it will round, I am giving a random normal values. R norm means random normal values from, I want 10 values with a mean of 25 and standard deviation 2. and I want the rounded values till 1. Like I don't want any decimal, it should be a whole number. So I am saying till 1 value. So you can see what I have done is I have given the age from random normal numbers, 10 values with the mean of 25 and standard deviation 2, and rounded till 1 decimal point. Next is gender. So gender is in male or female. So what we are doing is we are using the command sample here. For sample command, what we'll do is we'll combine these two, that is male and female, and I want 10 values of male and female replaced 10 times. Like there will be 10 values, as I have 10 names here. I want 10 gender values replaced every time, as there are two only. So it will take. So now let's create a data frame from these values. We have created roll numbers, name, age, and gender. Now let's create a data frame out of it. The name I have given to the data frame is df2, and the command is data.frame. I am giving the name of all the variables that I have saved earlier. So I have created roll number, name, age, gender. So the name of the variable should be in the sequence in which you want the column sequence. Let's print the value of df2. So you can see I have 10 values here. Each column is of different data type. You can see first is a numeric form, second is a character form, again then there is numeric, and then there is logical. Last is in the form of character. You can also check the class of this data frame. You can see it is in the form of data frame data type.